So now we're getting somewhere, aren't we? We understand now what Express comes into play. It is our web server. We're bringing it into our application. And the way we're bringing it in is a very standardized way. So before we talk about Express specifically, let's talk about it in more general terms to make sure we understand what's going on. When we bring Express into our app, in fact, what we're doing is we're bringing a CommonJS module into our application. And how do we make sure that that dependency is communicated to everyone who's going to be in our code base? Well, we defined it in our package.json file. We defined it in our CommonJS packages file. And how do we install Express.js? Well, we actually use a library that is very definitely not short for Node Package Manager. At least that's the official party line. So let's talk about how to bring something like Express in so we know how to bring anything into a Node app, not just a web server. So CommonJS has an interesting history as well. Not surprisingly, it came out of the Mozilla organization, but surprisingly, this wasn't a specification for bringing in client-side dependencies. Kevin Denger said, hey, you know what? I want to find a way, a standardized way to bring in libraries outside of the browser. He originally calls his specification Server.js, but very quickly it moved on to CommonJS. But CommonJS, as the name implies, is a way to deal with JavaScript modules in a common way outside of the browser. So there are a number of different specifications that fall under the CommonJS umbrella. We're going to focus specifically on the module specification and the packages, but you'll see the idea of promises, the way of dealing with asynchronous requests in almost a synchronous way. That falls under this umbrella as well. And that really helps us emphasize the fact that these are specifications, these aren't implementations. So promises is implemented very differently in jQuery than it is in AngularJS, than it is in a server-side library like Q. The concepts are the same, but the syntax or the implementation is different. When we look at the different environments that are CommonJS compliant, then you begin seeing what the power of this really is. Certainly Node.js is there available to us, and you don't need to be reminded at this point, right, that Node.js is based on Chrome's V8 JavaScript engine. But let's say you're a Java developer. Did you know that since JDK 1.6 you've had a JavaScript runtime included with you? Absolutely. You have a project called Rhino. And what is Rhino? Well, SpiderMonkey was written in C and C++, but when Sun Microsystems came along and formed that strategic alliance, they ported the C library to Java and named it Rhino. So if you're a Java developer and you're interested in running an application server based on Rhino, you'll be interested in using a framework like Ringo.js or Vert.x. Those are both Node-like libraries, but they're built on top of the JVM's runtime, not V8. As a matter of fact, Rhino, interestingly enough, 1.6 is an old platform, right? 1.6 Rhino has an ECMAScript 3 capabilities. That's about Internet Explorer 6 era capabilities. And when Java 1.8 came out, they had upgraded that. They upgraded it to ECMAScript 5 capabilities, and when they rewrote the library, they gave it a new name. It's no longer called Rhino, it's called Nashorn. And if you sprechen Sie Deutsch, you know that Nashorn is German for Rhino. So we have libraries like Ringo.js and Vert.x and Node.js that are all based on the CommonJS specifications. What this means is I can't turn around and run Express on Ringo, because Express is built on top of the HTTP library that's native to Node.js. Now, Ringo and Vert.x, they could provide similar libraries, but what we do end up with are libraries that don't have underlying platform requirements. If you have a good string manipulation library, a good collection library like underscore or Lodash, if it's a CommonJS library that doesn't have hard dependencies on the platform it's running on, if it's a pure JavaScript module, you could just as easily bring Lodash into a Node.js project as you could a Ringo project or Vert.x. You'll also see in this list that there are a number of NoSQL stores that are CommonJS compliant, specifically CouchDB, specifically MongoDB. And so what this means, once again, is JavaScript, the language, runs across all of these. But you'll have a different set of APIs available to you. And so CommonJS is a way for bringing in those third-party modules in a consistent, reliable, repeatable way. Now, if we went and started looking at ExpressJS's source code itself, there are many different ways we can see that they're based on ExpressJS modules. One of the things we could do is we could see that they said in the comments, these are my module dependencies, and we know that comments never lie. But more importantly, we see this require coming in. We see us bringing in the event library. We see us bringing in the router and request and response and good things like that. That's one indication that this is predicated on CommonJS. Another one is there on line 17, where we export a method or a series of functions. And this is another key factor when it comes to CommonJS modules, is where JavaScript is not just a little bit global, it's pathologically global and pathologically public. Modules give us the ability to have private variables, private functions defined. As a matter of fact, everything in a CommonJS is private, everything in a CommonJS module is private, unless you explicitly export it. And the functions and variables that you export, module.exports, become a part of your public API, and the ones that you don't, in fact, remain private. And this is very important for us to pay attention to, because this privacy, this notion of encapsulation, is one common thing that we miss as we're coming from different languages into JavaScript. And what's so nice is that CommonJS provides us this level of functionality. But this level of functionality is going to be baked into the language. When ECMAScript 6 becomes mainstream, we're going to have these features available to us. But in the meantime, CommonJS has served as a wonderful polyfill, a wonderful way to bridge the gap between features that are available natively and features that are about to come. Because folks who were doing web development in the 1990s, in the bad old days, took a lean back approach. They said, we can't program to the front of the pack, we have to program to the weakest animal in the herd, the slowest animal in the herd. I won't mention any names, IE, but most of the people ended up saying, well, if it can't run an IE6, well, then we can't run it at all. And what did that do? It slowed down our velocity. It set us back a decade as we're waiting for one vendor to catch up with all the rest. So in fact, in this new modern HTML5 era, what we do is we lean forward, not back. We assume that everyone has the most modern set of libraries, the most modern browser, the most modern render kit and JavaScript engines. We'll program to ECMAScript 6 capabilities. And those browsers that haven't yet caught up will provide polyfills for them, backfills for that functionality. In fact, CommonJS is really just a polyfill for ECMAScript 6 modules. But it's a very powerful polyfill, widely used, and we'll continue to use that until ECMAScript 6 becomes mainstream, and then the need for this will eventually go away. Like all good technologies do, it served its purpose when it was needed, but it's been supplanted by a more standardized approach. So when you're thinking about CommonJS modules, the things you need to pay attention to is you require them in. And recall that when you require in a CommonJS module, it brings in not only that core library, but all of its dependencies as well. When you require an Express, you got request and response and the event handlers for free, because modules are able to define their dependencies and bring in those transitive dependencies when you bring in the parent module. You can have private fields and methods. Finally, if you don't export them, they're yours, but if you do, it becomes a part of your public API. So now that we know a little bit about CommonJS modules, how do we package them up? And really what we're doing is, how do we go from a single library or a single module to a collection of related modules? If by requiring in a module we can bring in our transitive dependencies, how do we declaratively define what our transitive dependencies are? And this is where our good friend, the package.json file, comes in. Package.json is required if you're going to be on the Node.js stack. If you're going to be doing Node development, you've got to have a package.json file. But it's not bad. In fact, it's kind of nice. It gives you one place to put all of the metadata about your project. You can go in and give your project a name. You can give it a version, not just any version, but a semantic version, something we'll talk about in just a moment. But you can give it keywords, you can give it authors, you can tell people where your repository is, you can tell people where your bug tracker is. There are lots of good things you can do about the metadata about your project, metadata geared towards programmers, humans. But you also have metadata provided to the runtime, to build scripts, to NPM. And these pieces of metadata are things like the dependency block. The dependency block is where you define your runtime dependencies. There's also a dev dependencies block, and that dev dependency is, as the name implies, where you define your developer dependencies. So the things you'll find in a dev dependency block are things like build scripts and testing tools. The things you'll find in your dependencies block are things like database drivers and web servers and modules like that. So when we're looking at package.json, we'll find that there's a package.json in a remarkable variety of places. As you're looking around in these libraries up on GitHub, you'll see package.json almost anywhere. It shouldn't surprise us that Express has its own package.json. And when we pull it up, we can see who wrote it and what version we're at and how it's licensed and what our keywords are. Are you surprised a little bit that you'd find a package.json file in the Angular project as well? I mean, come on, AngularJS, that's a client-side library, right? CommonJS was about running modules outside of the browser, and Angular runs firmly inside of the browser. So why on earth would Angular have a package.json associated with their project? Well, if you read it, it's all developer dependencies. If you check out Angular from GitHub and you want to build it on your own, you can type in npm install. Not npm install an individual project, just type in npm install. And without a third keyword in that npm install, we'll look for a package.json, look for the dependencies block, look for the dev dependencies block, and download them on demand. So what this means, when you do an npm install, those files are going to go in your node modules directory. It'll be created if you don't have one. You should git ignore that node modules directory. You don't want to check in those dependencies because they're artifacts at this point. And if you're defining them well in your package.json file, there's no need to carry around all that. That's simply ballast. What you do is you check out your project, and with a well-formed package.json, you type in npm install, and you've reconstituted the application. You've pulled down the bits that you need in order to either build your app or run it. So before we leave package.json, there's one key thing that we need to mention, and that's Semver. Semver.org, or semantic versioning. It came out of GitHub, and what they said is, you know what, we understand what these version numbers mean, but let's put a little bit more semantics behind them. Every version number you'll see in a package.json file, every number you'll see when you're dealing with CommonJS modules, has three key pieces to it. It's got a major version, it's got a minor version, and it's got a patch level. And if you use these version numbers in a semantically appropriate way, they're amazingly communicative. They really tell you where you are in the project. So let's start with the middle one, the minor version. Of the project I'm on right now, we have weekly iterations. And so every Friday afternoon when we cut a new release, we're revving that minor version. We go from 0.12 to 0.13 to 0.37 to 0.56. The idea behind that minor version is it's trying to demonstrate forward progress in a backwards compatible way. As we are moving up to our 1.0 release, we're not there yet. We're continuing to add new functionality to our app, so we're continuing to rev that minor version number. At some point, we're going to say, hey, we've got everything in place, we've got our MVP in place, our minimum viable product, and so we're going to officially cut a 1.0 release. And so you can see then we've got our major milestone in place. Now, as we added additional features in a backwards compatible way, we could continue to move on to 1.1, 1.2, 1.3. But at some point, we're going to do a major refactoring. At some point, we might change our persistence from Mongo to Cassandra. We might change core pieces that change our app in a non-backwards compatible way. And that's when we would be looking to move from 1.0 to 2.0. AngularJS, in fact, is going to be doing that. AngularJS 1.x right now is predicated on scopes and directives and a number of things we're going to talk about later in this presentation. But when Angular 2 comes out, it's going to be based on web components. It's going to be based on ECMAScript 6 core browser functionality. And they're using semantic versioning appropriately to signal to you that Angular 2 is very, very different than Angular 1. But what about that patch level? Well, we cut a release on Friday afternoon, and since we're normally drinking by 9 or 10 on Friday, we always end up having a couple of patch levels. We released 0.37.0, and then, we forgot to concatenate and minify. So now we've got 0.37.1, and we forgot to include this other library in the package JSON. So we have 0.37.2. You get the idea. When you make mistakes in a minor release, you rev the patch level. When you add new features in a backwards compatible way, you rev the minor level. And when you have major changes in a non-backwards compatible breaking way, you rev the major version. Now, by using CommonJS and package.json, you're not guaranteed that everyone in the Node.js ecosystem is using semantic versioning in the right way. But that doesn't mean you can't use it in the right way, because it really communicates the state of your application, and as you have new versions, it communicates in a non-specific but very reproducible way what this new release brings to the party. And so if you have CommonJS modules under your belt and you understand the value of package.json and semantic versioning, then we can focus on NPM. Now, if you ask me, it stands for Node Package Manager, but if you ask the people who wrote it, they said absolutely it does not stand for that. Who are you going to believe, the people who wrote it or me? But whatever you call it, NPM is the way that you're able to install third-party modules. If you go to npmjs.org, that's npmjs.org, you'll see a list, a big list, of all the available NPM modules out there. At this point, I go out to NPM and I can see there are almost 140,000, or 130 and some change at least, 130,000 different Node modules out there. When I started teaching this class several years ago, there are only 40 or 50,000 modules out there. So you can see CommonJS is widely adopted, but writing JavaScript libraries is kind of like punk rock. Anyone with a browser and a free GitHub account fancies themselves a Node module maintainer as well. So one of the most important things out of NPM is not just discovery, but the metrics behind this app. When I start looking at Express and I see that it is at version 4.12.2, just by looking at those version numbers, I can tell that they deeply get semantic versioning. That they released 4.12 and then after the beer buzz wore off, they had forgotten to include some dependencies, and so they revved a couple of those minor patches in there. But I can also see not that they're using semantic versioning, but this is a well-used library, a well-loved library. NPM shows me the number of downloads per day, per week, per month. So I can see, is this a library that's been downloaded 4 times in the past month by the developer and her mother and 2 other people on her team? Or can I see, is this a very popular library being used across the board? A good set of documentation helps me trust this library as well. Do they have a simple hello world? Do they show me how to install it? Not surprisingly, npm install express is how we'll get it. So everything about NPM is a way that I can use this as kind of a canary in the coal mine to gauge the health and vitality of this project, to make sure that I can trust this. And if I don't, there are 129,000 other projects that I can evaluate. So now that we understand the value of CommonJS modules, the value of package JSON and semantic versioning, and the value of NPM to bring in these third-party libraries, what do you say we bring in a third-party library like Express?